Hello and welcome. Today we have before us an important topic, Laws of Indices. It happens to be a basic law in maths for most operations that will be done at a very elementary level in mathematics. When I mean elementary, not exactly elementary, but I mean when you're coming up, you need to know the laws of indices and their importance. And let's take a look at some of them, and in the next class we'll continue. Now what we have, first of all, what is the law of indices? It is also called the law of exponents and also called the law of power. It is the law that governs the operation and powers of powers. Now we'll look at one of them, about four of them. The first is the product law, the exponent, the quotient law, the power or power law, and then the power quotient. Now let's pick the first one. The first one is, now the first is the product law. What that law states is this. Now you have an item. When two items have the same base, you would have to add the two of them. When the product of a particular this has the same base, you have to add the both of them. Now you have, in this case, as a raised to the power of m multiplied by a raised to the power of n. What that law states that once the both of them have the same base, what you do is to use a single base for one for the both of them, and then have this as n plus n. Now let me look at a very simple way of remembering it. Times is like turning it this way. Turn it this way and let it stand. It becomes plus. So what you do basically here in this product law is that you will turn this in here to plus, just a way of knowing it. So it's going to become this. This is what you have. Now let us use, I'll do two examples to prove this. Now first I'm going to use figures. If I have the first example, if this m represents 3 and this n represents 2, let's see what happens. For example, a raised to power, or let's even use numbers. Let's say 2 raised to power 3 times 2 raised to power 2. Now this means 2, since both are the same base, you have 2, 3 plus 2. This times becomes like an addition. That is what the law states. So what you have is 2 raised to power 3 plus 2, meaning 5. Now let us prove it by multiplying all through. What is 2 raised to power 3? 2 raised to power 3 is the same thing as 2 times 2 times 2. And what is 2 raised to power 2? Is the same thing as 2 times 2. And don't forget this times here. Now let's multiply. How many 2's do we have here? 1, 2, 3, 4, 5. In essence, it is putting it as what? 2 raised to power what? 5. Now if I want to know what 2 raised to power 5 is, I have to do 2 times 2 times 2 times 2. 2 times 2 is what? 4. 4 times 2 is 8. 8 times 2, 16. 16 times 2 is 32. So 2 raised to power 5 is the same thing as what? 32. Now the second law quickly, quotient law. The quotient law is this. The second law, quotient law. What this states is this, that you have, for example, m raised to power a raised to power m and a raised to power n. This is what? Divided. A raised to power n divided by a raised to power n. It means a raised to power m. This, like, assume it's just a minus sign. Minus n. This is the law. Now, if we use numbers, just like we've done with this, to test it, we'll have, let's say this becomes 2 again. It's like 2. Let's say this is 4. Or let's say, let a be 2, and let m be 4, and let n be 2. Or let's say 2. Now, what happens? Here becomes 2 raised to power what? M is what? 4 divided by 2, because a is 2, raised to power n is what? 2. This n is this 2. So what does that mean? It means here that now the two of them are the same base. You bring it out here, you use the same base as 2. This division, see it as a minus sign. So it becomes 2 raised to power, this one, raised to power 4, this becomes a minus. No need to replicate 2 again, all over 2. So what is 4 minus 2? 4 minus 2 is what? 2 raised to power 4 minus 2 is what? 2. 4 minus 2 is 2. Now, this is the answer if we substitute with figures. If we decide to go the other way around, like we have with this, just go straight. What does it mean? If we have, or you have it in this way, 2 raised to power 4 all over 2 raised to power 2. Now, this is divided by, or raised to power, this is 2 raised to power 4 divided by 2 raised to power 2. So what is 2 raised to power 4? 2 raised to power 4 means 2 times 2 times 2 times 2 divided by 2 raised to power 2. That is 2 times 2. So if we divide, this will divide this, 1 here, 1 here. And 2 here, 1, 2 here, 1. What's remaining here? It means 2 times 2. 2 times 2 is what? 4. And, or just let's even leave it out. 2, how many 2's are here? 2. 2 raised to power what? 2 divided by 1 times 1 is 1. So any number divided by 1 is still 1, right? So what we have here is what? 2 raised to power 2 divided by 1, which is written as 2, right? Anything divided by 1 is still 1. So in essence, this answer is the same as this. If we do it out, work it out, this is 2 raised to power 2 is the same thing as 4, and 2 raised to power 2 is the same thing as 4. Now, having done this, we'll go straight. In a recap, we have done the product law and the quotient law. Now we'll go to the power of power law, which means that a particular number is raised to a particular power and then also raised again to another power. Now let's see an example. Let's take this off. Take this off. Now, if I have it this way, now this number 3, power of power law. This law states that when a is raised to power m, also raised to power n, the bracket will stand as a multiplication. Now remember in the other one, this one, the times will be changed to plus. But in this case, this bracket will represent the times. What that means is going to be, what that means it is a raised to power m times n. Now, what that will mean now if we substitute with values, let's take the same values we used here. If a, or let's use some other, if a is equals to say 2 and m is 4 and n is, let's say, 3, what would that give us? We come to this place, we say a raised to power 2, a raised to power 2. So a is 2 raised to power m, which is 4, into bracket n is 3. The law is saying that this is like making here a multiplication sign. So we have it as 2 raised to power 4 times 3. 4 times 3 is same as 2 raised to power 12. 2 raised to power 12. Now that's basically what this law says. The power of power law. Now without much ado, we'll go to the next. The next will be the last we'll be considering for today. And then the next class will go to the next. The next is the power of a quotient law, of a quotient. In this, we have, for example, a raised to power b all over m. Now this is a quotient. What happens here? It means a raised to power b, okay, a raised to power b, a divided by b, or raised to power m. If I want to split this, I can make it different by separating it. This will mean that a is raised to power m and b is raised to power what? M. Now this is still division sign. It's still the same thing as saying a raised to power m divided by b raised to power m. But basically we'll stop here because of this. Now if I have or substitute with values, okay, if I have substitute with values, for example, we can have, let's say a, let's use arbitrary figures. Let's say a is 2 and b is 4 and m is 3. What we'll have here is going to be this: a, which is 2, all over b, which is 4, all raised to the power of 3. If we solve this again, it's going to be a raised to power, 2 raised to power 3, all over 4 raised to power 3. So what we have here is this: 3 raised to power 2 is going to be 2 times 2 times 2, all over 4 times 4 times 4. Spread it out, which is about this. This is just what it means. Or we bring it here as 2 raised to power 3 divided by 4 raised to power 3. But basically, like I said here, we'll stop in this place. This is what it means. Now, in the next class, we're going to go to the other 8 laws, the other 4 laws that makes it 8 at this level. So thanks so much. Now, if you have a question or a comment, please put at the comment section. Thanks so much for coming to class today.